Good morning, all of you. This is Rahul Lagnu Kalel, Dr. Rahul Lagnu Kalel, working as a Assistant Professor, Department of Chemistry, Vivekanand College, Kolhapur. As we have already discussed, we are going to study the photochemistry for a BSc 3 chemistry students. Today we have to discuss the next point of our syllabus, that is photosensitized reaction. First introduction. As we already know, the first law of photochemistry, that is Grothus Draper's law, states that the only those part of light which is absorbed by a reacting system is effective, or that is responsible for carrying out a photochemical change. It means that the light must be absorbed by a reactant to carry out a photochemical reaction, right, according to first law of photochemistry. Now see, in the universe it is observed that most of the molecules are unable to absorb the light, even though those molecule undergoes a photochemical changes. How it's possible, right? To know that, we have to study the photosensitized reaction. Now, not all the molecules in the universe are able to absorb the light, but they undergoes a photochemical changes. How it's possible, right? Suppose you just consider only few or certain molecules have a tendency to absorb the electromagnetic radiations in the UV and visible region. Only certain molecules, right? Now see, sometimes what happen, if an electromagnetic radiations have a sufficient energy to react those molecules, but due to that molecule's tendency or ineffectivity towards the electromagnetic radiations, directly that molecule is unable to absorb those radiation. In that case, there need, or there it is necessary to be another molecule or foreign molecule that should be absorbs the energy from the electromagnetic radiations, and it should transfer that energy to the reactant molecule, right? Once any molecule absorbs, see, any molecule absorbs the photon or light, right, then this molecule goes to the excited state, right? And see, there are two possibilities. In the excited state, certain molecule have a tendency to pass its energy to the other molecule when it collides with the other molecules, but certain molecule are unable to transfer this energy to the other molecules. Suppose in this case, in first example, you just consider this molecule A, due to absorption of a photon it goes to the excited state, and at the excited state, when this molecule collides with B, right, then due to tendency of this molecule, the molecule B is not getting activated, because this molecule is unable to transfer its energy to the another molecule, right? But consider the another case in which that molecule, suppose X, that absorbs the photon, it goes to the excited state, and at the excited state, if this molecule is collides with the another molecule, that is B, then due to its tendency to transfer energy to the another molecule, the another molecule B is also getting activated. See, in the first case this molecule B is not getting activated, but in the second case molecule B is getting activated. Means this molecule X absorbs the energy from the electromagnetic radiation and transfer its energy to the other molecule. This is the tendency to a certain or some molecules are there. Now if our B is a reactant, but see, B is unable to absorb the photon, so if we irradiate this B with the electromagnetic radiations or UV light, then no reaction is takes place, right? And the another foreign molecule X, it has a ability to absorb the photon, but due to absorption of a photon only by X, the desired product formation is not there. So when in our reaction system these two molecules are present, B and X both are present, our reactant is B, X is another molecule, that is called sensitizer, right? So what happen, this X absorbs the energy from the photon and transfer that energy to the B, our reactant molecule, that is B, and then it leads to formation of a product, right? Hence this photosensitized reaction are defined as, see, in some reaction the reactant molecule is unable to absorb the energy or to acquire the energy from the light itself, right? In that case, some another molecule is present in our reaction system. That molecule absorbs the energy from the light and that transfer that energy or pass that energy to the reacting molecule, and hence the reaction is completed or takes place, right? Hence, see, this kind of reactions are called photosensitized reactions. And that foreign molecule, that is light absorbing molecule, it's called sensitizer, right? It is this kind of reactions are also called indirect photochemical processes, right? Generally, in the example, most of the photo oxidation reactions are the photosensitized reactions, right? While discussing the example, first we will discuss the example of dissociation of hydrogen molecule, right? See, this is the hydrogen molecule. Now, if that hydrogen molecule is irradiated with the UV light having wavelength 253 nanometer, right, then even though that UV light having energy that is sufficient for dissociation of this hydrogen molecule into the its two atom, but the direct irradiation of UV light with hydrogen molecule doesn't leads to formation of a or doesn't leads to the dissociation of that hydrogen molecule, that to form two hydrogen atom. That reaction is not possible even though energy is sufficient, but reaction is not possible because hydrogen is unable to absorb the UV light, right, having wavelength 253 nanometer. In that case, if a small amount of mercury vapors or a mercury atom is present in our reaction system, in that case what happens, the primary photochemical process is that mercury vapors absorbs the photon or that UV light having wavelength 253 nanometer, and that mercury vapor goes to the excited state that leads to formation of a Hg star. And see, this excited mercury reacts with hydrogen molecule, means that absorb energy transfer to the hydrogen molecule, and then dissociation of hydrogen is takes place with, again we back the mercury atom or mercury vapor as it is. This mercury is not undergoes any photochemical change, but it acts as a sensitizer. See, in this case, this mercury vapor or mercury atom acts as a sensitizer, and our reactant molecule is H2, and our product is two hydrogen atom that is getting dissociated hydrogen molecule. This is the best example of photosensitized reaction. The another example of a photosensitized reaction is that is the well known, it is a photosynthesis. In that case, everybody knows that in the atmosphere carbon dioxide is there, water vapors are also there, also sunlight is there. Even though without presence of a green plant, the production of oxygen is not possible, also the formation of glucose is not possible in the atmosphere, right? But when the green plants are there, inside the green plant, right, it absorbs the CO2, water, right, that green plant, and in that the sensitizer, that is photosensitizer, chlorophyll pigment is there. That chlorophyll pigments absorb the energy from sunlight, and then it transfer this energy to the our reactant molecule CO2 and water. Then only it leads to formation of a oxygen. That oxygen gas is evolved out in the atmosphere. This is the best example of photosensitized reaction. Mostly the oxidation reactions, that is photooxidation reactions, are the photosensitized reactions. Thank you.